I'm excited now to bring in our first presenter. Welcome, Matt Kyle, Director of Product Marketing at Cequence Security. Matt, it's great to have you on. Take it away.
Thanks, everyone. Thanks for having us. And thanks for the audience for their attendance. What we're going to do today is talk a little bit about cloud-native security and how you can accelerate it. When we think about the topic of modern applications, most of the definitions would probably include some sort of a cloud deployment, whether it's any one of the big three or one of the others public cloud environments. And you'd probably also equate that definition to moving towards a more modular, containerized, or microservices-based application architecture. So those are going to be the topics today. And obviously, at Cequence Security, a security company, we're going to talk about how you can secure those applications without injecting friction. So a little bit about the company. We've been around for a while, founded in 2016. We just landed our Series C funding, so we're still in a venture-backed mode. We are a API security platform with customers in financial services, retail, social media, and other verticals. And the differentiator that we bring to the table is that we're really the only API security platform on the market that approaches the problem of protecting your APIs from a prevention-first perspective. That was where we started. We started in the automated attack prevention era, and we've expanded that functionality to be to focus on API security and analyzing those APIs and assessing their risks and helping you fix them. So let's get started. So when we think about cloud-native security, it's going to be very complex, right? It's going to be lots of different containers or microservices, perhaps in multiple clouds, multiple container environments, all connected with each other, right? So, you know, how are you going to inspect, audit, and track those changes as your developers are rolling out new code, you know, perhaps as frequently as every day or even more frequently? How are you going to apply application security policies? What are you going to do to govern the services across each of the different environments, both internally and externally? And then another question is enable secure development, maintain reliability and uptime. And then the final element that adds complexity to what is already a complex environment is security policy consistency. Again, if you're like many organizations, you're moving towards a multi-cloud environment. If you're an older organization that may have legacy applications still in a data center, you might have virtual machines connecting back to the cloud. How are you going to maintain consistent security policy? So one way to do that is to work with Cequence and Tetrate, who we have just established a partnership to manage cloud-native applications, I should say, securely. So we've established a partnership. You guys are going to actually hear about it before the press hits the news. There'll be a press release tomorrow. But we've partnered with Tetrate to integrate with their Service Bridge, and we're going to talk about the Service Bridge in just a moment. What we end up doing is helping you reduce complexity, improve the efficiencies of your operation, and deploy security in a frictionless manner. So a little bit about Tetrate. So the Tetrate Service Bridge, what it does is it's an overlay for your container-based environment, whether it's Istio or Kubernetes or any one of the different variations. The Tetrate Service Bridge is what you would call a management overlay. So it's going to allow you to manage your microservices, whether they are brand new microservices or even the legacy applications, in any location, in any application architecture. So they're helping you reduce the complexity of application networking, giving you the ability to monitor the services, establish policies, watch and monitor the connections between the different services, those types of things. It's going to enable those developers to more securely and more quickly expose APIs, making sure that internal APIs are not exposed externally, those types of things. So it really does help you bring some semblance of normalcy to the chaos that you might be experiencing in your container-based environment. So let's talk a little bit about Cequence. I am going to delve into how Cequence can help deliver application-level security. So that application-level security that we would deliver is complementary to the Tetrate network level security that they give, giving you that full stack security, if you will. So we are a API security platform. The API Sentinel is one of the two pillars. The other one is bot defense. API Sentinel is going to give you that visibility and discovery and visibility and inventory tracking of your APIs. So we will integrate with the Tetrate Service Bridge. We can also integrate with many of the other API management components, things like load balancers, API gateways, CDNs, and other service mesh environments to give you that visibility into your APIs. We then will analyze those APIs for risks and look for threats within them to operationalize API security, if you will. Bot defense is going to look at that traffic flow, looking for signs of automation, looking for signs of malicious use, malicious users hiding in plain sight. It'll give you that information and then allows you to use one of the predefined policies or create your own policy to begin preventing those automated attacks. Everyone's heard about the Grinch bots that pop up every holidays. The bots that will go out and purchase the high-end sneakers or the game consoles. That's exactly what we're talking about here in terms of the bots will attack the APIs and give themselves an unfair advantage when competing for those precious Xboxes, PS5s, NVIDIA cards, or sneakers. So let's talk a little bit more about that in detail. So first thing we're going to do is the discovery and inventory tracking. So going to find all your APIs, both those that might have specifications and those that may not. These are going to be shadow APIs or hidden endpoints. We're going to it's going to allow you to upload an Open API 3.0 or 2.0 specification to the platform. It will then use that for conformance checking and other purposes that I'll talk about in just a moment. A new feature that we're rolling out is it will now also allow you to generate a specification. So not only can you use specifications to do conformance checking, but it will also generate a specification. And the value of a specification really is it's a step towards more complete documentation of your APIs so that you can, one, improve quality, and two, improve consistency, and three, of course, improve security. So there is hidden value in that specification capabilities. We're going to use the information that we're collecting to look for traffic patterns, malicious use, those types of things that can then be built into a policy for defense purposes. Next thing you're going to do is we're going to assess the risks. So there are predefined risk assessment rules. The standard ones are authentication. So it's going to look at your APIs to make sure that authentication mechanisms are in place, make sure that strong authentication mechanisms are in place. It's going to look for sensitive data patterns within the API communications. And it's going to also look, like I said, at Open API specification conformance. And it will also allow you to create your own risk assessment rules. Any of these risks are flagged on a score of 1 to 10, categorized low, medium, and high. You can then initiate alerts and remediation tasks directly from the product through the tools that you see listed there. So very powerful capabilities, allowing the security teams and the development teams to work hand in hand to make sure that the APIs are protected, but you're not placing an extra or undue burden on the development team to learn different tools or to add yet another tool to their already heavy tool-laden arsenal. Prevention. So, APIs exposing sensitive data. This is a drill down into what you would see when you're looking at sensitive data. Sensitive data discovery here would be used for data governance. So looking for APIs that might be exposing sensitive data, putting a financial services organization in jeopardy of violating their PCI compliance, or looking for personal information being shared without it being masked or encrypted. So very powerful capabilities. You see the different data patterns that we support there, credit card numbers, social security numbers, stack trace codes, and then you can create your own custom data patterns for analysis. Here too, much like the previous slide, you can initiate alerts and remediation tasks through Slack, email, and other collaborative tools that you might have in your arsenal. Finally, automated API threat mitigation. One of the lines that we use to describe the problem statement that our customers are facing is, their development teams love APIs. APIs have been around a long time. They've exploded in the last few years as the effort to modernize applications has exploded. The move to the cloud, the move towards containers, the move towards mobile devices, all of these components, all of these elements, I should say, are influencing the use of APIs dramatically. And for the same reasons that developers love APIs, so too do attackers. It's far easier for an attacker to find an API and exploit it, or launch a script against an API for an automated attack than it is for them to attack a web page. The reason? Well, APIs are inclusive of the full transaction, so they just write the little snippet of code and they fire it at the API. A web page, you still have to figure out how to fill in the forms and move the automated attack along the web page. So it's very, very powerful. So what we do here is we use ML models to differentiate between genuine and fake requests. So this is something we've been doing now for five years or thereabouts. So looking for automated threats, hiding in plain sight, appearing to be legitimate users. I described the GrinchBot capabilities earlier, so we don't need to go through that again, but that's exactly what we're doing. We're helping our retail and finance customers sniff out those automated, malicious users hiding in plain sight, trying to achieve account takeovers or create fake accounts or do content scraping attacks against our customers. So we're going to look at API usage-based spikes. We're going to look for unauthorized use, people that are trying to brute force their way into the application. Look for the APIs originating from known malicious IP networks, things like bulletproof proxies, where they are reselling or using residential IP addresses that have been compromised and distributed around the world to make themselves appear legitimate, hide their identity, hiding their location. So if you were to do a Google search for bulletproof proxies, you'd find a host of different proxy vendors out there selling their IP address ranges to malicious users for the purposes of exactly this, launching large-scale attacks. They mask themselves as legitimate businesses because there are uses where you can subscribe to their services for testing. You want to test your website, you want to test a high-volume website, then you might use this type of a service. But really, the underlying use case for them is malicious use. So just a few examples of the automation that gets launched against APIs. So let's talk a little bit about our architecture. So it's a modular architecture separated into a control and data plane. The data plane is a lightweight element that connects to your your network component that you see there on the bottom of the screen. It's going to connect to your CDN, load balancer, gateway, proxy, or controller, and it's going to feed information back to the control plane that might be hosted in a SaaS environment. It might be hosted in a data center, or it could be a hybrid approach. So the control plane is where all the heavy lifting is done. So it's done in a manner that does not inject any performance degradation to your application, and little to no latency in the application. Which is obviously very critical for any of the financial applications, the retail applications that we might be supporting. So now, when you look at keeping this in mind, the componentization of the application, control plane, data plane, the way that we would then be deployed in Tetrate is as you see here. So the Tetrate Service Bridge deployed on the left side there of the screen within the container environment. You see that we would be integrating, in this particular case, to the API gateway that is in use in the Tetrate Service Bridge environment, collecting the data, sending it to our API Security Platform to do the analysis. Any enforcement that is done, the findings are delivered back to the inline component here, known as the defender, to take action. So we can, and that can be as simple as log the information, or it can be as complex and or involved as sending a deceptive response back to the attacker. In between those two extremes would be rate limit, block, and geofence. So different responses are available as needed. And as you see there on the right side, in this particular case as well, you can support a SaaS environment, on-premises, or a hybrid environment. All right, rocking and rolling. So when we think about the topics of the EcoCast today, enabling modern applications, you really do need to think about the use of APIs, the use of modular or more iterative development methodologies, the use of containers, service mesh environments, and you might want to come up with, you need to then think about how are you going to manage it and how are you going to secure it. So with the partnership that we've established with Tetrate, you're going to get the ability to manage cloud native applications, manage their complexity, simplify things a little bit. With Cequence integrated into the service bridge, we can help ensure that the web apps and APIs within those environments are protected. Now, one of the things that I actually forgot to talk about, I'm going to go back a slide here real quick. The way that it works, the way the integration works is there is a small snippet of YAML code that is actually included now in the Tetrate Service Bridge libraries that allows you to add that code to the Tetrate Service Bridge environment into each one of the pods that you see there. So when the traffic is flowing through and if you're a Cequence user, or you can actually add the application to the Cequence environment at the development stage, long before it ever gets to the security teams. So, and then when you deploy that application, the security team takes over and begins protecting those applications automatically. So there's no change control process, there's no delays that are injected into the rollout. The applications can be deployed and protected as fast as the development team can keep up with. So that wraps up our conversation about Tetrate, how Tetrate and Cequence can help you secure modern applications. I'm going to open it up. There's a couple of questions I think that we have available. Moderator, do you want to jump back on? David?
Absolutely, yeah. We do have some great questions coming in for you from the audience, Matt. While we take those questions, I'm just going to bring up this poll for everyone out there that says, what additional information would you like about the Cequence solution? And we appreciate your feedback on that. Let's see, there's some great questions here. I guess I'll start off. There's a couple of questions around kind of monitoring and measuring from Harvey. How do folks monitor, what's going on with their API traffic and kind of measure, the effectiveness of the Cequence solution?
The Cequence operates at runtime. So it's a continuous process. So you can set the refresh rates, if you will, to be instant, or you can set the refresh rates to be, every few minutes. So as API traffic is flowing through the Cequence, flowing to your applications and therefore Cequence, you're going to see all that information in real time. So it's pretty seamless. And as I showed in the architecture diagram, there is little to no latency injected into that API traffic stream.
Excellent. And then there's another question here. They're asking about, would this solution cause any sort of latency, with the API traffic?
So there is a very, very slight amount of latency because the Defender component is extremely lightweight. All the processing is done on the back end. The average latency that our SaaS environment is injecting is less than 5 milliseconds. So that's pretty minimal. If there are metrics that you can set that will fail open, that will basically turn off the Defender if the metrics get too high, to again ensure that your application does not slow down or give your end users a poor experience.
Okay, excellent. And then what about notifications? Like when malicious traffic comes in, what sort of notifications are available?
You can set the notifications to be sent to email, Slack, any one of the number of different communication tools or collaboration tools that you might be using in your environment. All of the information that we collect can be exported via an API. So you can configure that API to send the findings for the malicious traffic out to another tool for logging and analysis, a dashboard, if you will. We have a integration documentation on the website for Datadog with Splunk in the works and will be finalized shortly. So any of the API, any of the information we have can be exported via the REST API architecture that we support.
Excellent. And then there's a couple questions here about, how the API Security Platform is licensed.
Is licensed? Yes. So licensed based on tiers per month, based on the volume of API transactions per month. So we start at around 1 million transactions per month, running up into the billions of transactions per month. And it's the number of transactions that we actually see. So when you license the product, you would say, we want to secure this set of APIs or this set of web applications, and the transactions are based on that, as opposed to your whole website, right? We're not going to be looking at your whole website or all the transactions on your web. We are just going to be looking at the critical applications that you decide you want to protect. Those might be the login endpoints that give you access to your financial records, the shopping cart of a retail site, the registration pages for a social media or a relationship site, those types of things.
Got it. Okay. And then let's see, probably the final question we have is, what really makes Cequence API Security unique in the industry compared to other solutions that might kind of claim to do something similar?
Sure. I touched on it very, very briefly up front, but we are the only ones that take the approach, solve the problem of protecting your APIs with a prevention-first approach. So all of the other folks that you've seen out there or popping up out of the woodwork are working more on the development side, trying to find and remediate errors that developers might make before they get published, which is critical. It's an invaluable step in the modern application development cycle, is to release more secure code as opposed to releasing error-riddled code. But even a perfectly coded API can be attacked very easily. So it's very important that you protect what you've got out there already, prevent those attacks against the APIs, while simultaneously helping the development team to uncover and remediate errors before they get published or before they get exposed to the attacker population. So it's a prevention-first approach is the biggest differentiator that we bring to the table, and we've been doing it for 6 years. We're protecting large retail sites from bots that want to buy up all the sneaker inventory, financial services sites, telecom. So a very, very rich set of enterprise customers use our product to protect those applications.
Very nice.
That's it. Yep.
Great. All right. Well, Matt, it's been great having you on the EcoCast today. Thank you so much.
Thanks, everyone. Bye-bye.
And for more information on Cequence Security, check out the Handouts tab there. There is a resource on the API Sentinel solution from Cequence. And, of course, we appreciate your feedback there on the poll.